Hi, my name is Akshay Kumar RN. My project title is Development of Solar Tracking System and Solar Cooking using Parabolic Reflector. My project or teammates are Udan Singh Gagrai, Sonu Kumar, and Rahul Kumar. We took help from Mr. S. Ravindran and Mr. G. Rajendra Prasad to continue my project and make it successful. An introduction part, I can say it's been a prior focus to enhance the solar performance with a bit of innovation added to it. This is the reason we selected parabolic reflector over photovoltaic panels. In parabolic reflector, the heat is concentrated on the focus of the parabolic reflector, but in PV panels, we use silicon plates and store energy in the batteries, which again has a bit of disadvantage that the battery terminals are need to be replaced from time and again. So now we are moving on to parabolic reflector. Parabolic reflector is a reflective surface which used to collect or project energy such as light, sound or radio waves. Its shape is part of a circular paraboloid. The parabolic reflector transforms an incoming plane wave traveling along the axis into a spherical wave converging towards the focus. So the focus point has larger amount of heat which can be used in many ways such as distillation or in very simple ways such as cooking. So this is the basic design what we have tried to make of, and as I move further to types of parabolic reflector, there are mainly four types of parabolic reflector: axial, off-axial, Cascade or Gregorian. Axial type of parabolic reflector, the efficiency is around 55 to 60%, and an offset feed, the efficiency is around 60%. In Cascade, the efficiency is around 65 to 70%, but it is using convex type of parabolic reflector, and we need not to feed its wave guides and front end. Electronics does not have to suspend in front of the disk. And the last one is Gregorian, which has the efficiency of 70%. This diagram shows the types of parabolic reflector. Further moving to stepper motor. A stepper motor is an electromechanical device which converts electrical pulse into discrete mechanical movements. With the diagram, it's very clear to explain. The electronic pulse goes to the poles, and the poles converts it, gives the mechanical movement to the inner liner, which is connected through a shaft, and it provides a stepwise movement. The other thing that we use in our electronic circuit is microcontroller. A microcontroller is a single chip that contains the processor, non-volatile memory for the program, volatile memory for input and output, or control unit. This is the figure to represent microcontroller. Later on, this figure represents the pin diagram of the microcontroller. A receiver is a vessel or tube-like structure where solar energy is concentrated with higher intensity such that some useful activities can be carried out. The structure of the receiver may depend on the type of work which is to be carried out. This figure represents the so photovoltaic panels arranged in a disk format, and all are built in such way that they all converge the solar energy to a focal point, and the tower above the tower, the white like structure, is the receiver. Further moving to list of electronic components used in our project, we have used a couple of motors, which is DC motors, stepper motors of 17 watt. We have used LCD, couple of integrated circuits, transformer of 1 ampere, a 12-volt battery, and LDR. The design of the solar tracking system is very simple. The increasing it has the increasing demand for energy, the continuous reduction in existing sources of fossil fuels, and growing concern regarding environmental pollution have pushed mankind to explore new technologies for production of electrical energy, which is clean, renewable, and very easy available. This has put forward to the mankind to use photovoltaic panels or some parabolic reflector to concentrate heat energy to points, or charge up the batteries in photovoltaic panel case. This is our design. In the design you can see the parabolic reflector, and these are the stepper motors which is connected to a battery, and the battery is connected to the electronic circuit consisting of microcontroller, transformers, timing chip, which is further connected to the AC supply. We have further added few more things in our project, like such as on application part we are using solar cooking. The, the light is concentrated to the solar energy is concentrated to the focal point of the parabolic reflector, and the heat energy over there is maximum, and it goes around 145 to 150 during 12 to 2 p.m. in the daylight, broad daylight. So we thought of implementing solar cooking in it. This is the simple technique of solar cooking. Just place a disk or some cookers receiver in the place of the focal area, and it is heated up. Within some time the food is being prepared. Further moving to the calculation of focus in the parabolic reflector, we all know that the focal parabolic formula is 4a to 6. So 4ay is the parabolic formula. So we are taking 10 and 6 point. So very easily we can say x square is equal to 4ay. So here x is 10 and 4a and y is 6. So the focus point is around 4.17 feet. This is another type of solar cooker, another diagram of solar cooker. Further moving to advantages, high heat can be achieved at focal point of parabolic draw. This heat can further be used in many ways such as solar cooking, distillation, etc. It is very cheap means of heating and very efficient because it follows the sun and intensity of heat hardly changes for the major part of the day. Lastly, it is purely eco-friendly and causes no pollution. At last, while concluding my project, I would like to thank my HOD, Mr. Jayavelu, and my college, Wiltech Dr. RR Dr. SR Technical University. Thank you.